Hi, everybody. So I'm going to do these for you, and I'd like you to really use this to practice. So either try the whole worksheet on your own and then come back and watch this video with me and see how you did. But even better would be to have the worksheet with you or just have a blank piece of paper with you. Pause me right now and do problem number one, and then hit play and see how I did problem number one and see if you got it right. Then pause me again, do problem number two, and then play me and see how you did on problem number two. That's the best way to get better at this. All right, so let's look at our first problem. We got problem number one. They're asking for f of 7. So the first thing I'm going to do is go look for function f. So I got f, g, h, and j up here. So this is my guy right here, function f. So f of 7, I mean, I'm going to take function f, and I'm going to replace x with a 7. That's what they're asking me to do. So f of 7, the -3 stays, the 5 stays, the x is tossed out, and in its place I'm going to put in a 7 and then a +8. All right, so if I'm looking at my order of operations here, I got parentheses. I'm going to do that first. Inside the parentheses, I have addition and I have multiplication. Or you could think of it as having two terms. Always simplify the term first. So I got -3, 7 times 5 is 35, plus 8. And I'm going to add 35 plus 8, which is going to give me 43 times -3. And am I going to use a calculator? Yes, I'm going to use a calculator. So 43 times 3 gives me 129. So 43 times -3 would give me -129. So f of 7 is -129. All right, pause me. Do this problem on your own. All right, so h of 2, I'm looking for function h. It's right here. So h of x is equal to x divided by 3 plus 7. They're asking me to substitute a 2 for x. So let's do that. Actually, I'm going to do that with my eraser. Give myself more room. So I'm going to replace the x with a 2 in parentheses, which means I replace the x with a 2 in the expression. Okay, so 2/3 plus 7. Do you remember how to do these? No problem. I need a common denominator. I need the same size pieces. So I'll put this whole number over 1. To make the denominator 3, all it needs is a factor of 3. So h of 2 is equal to 2/3 plus 21/3. So h of 2 is equal to 2 plus 21 is 23. Size of the pieces doesn't change. That's thirds. 23 thirds. Can I simplify that? No, 23 is prime. Could I change it into a mixed number? I could. If you really want me to. 3 goes into 23 7 times with 2 left over. So I could write this as 7 2/3. But I would be perfectly happy with 23 thirds. I'd give you credit for either of these on our next quiz. Problem number 3, j of -5. So let's find function j here. J of x is equal to 3. I'm going to change it to plus a -2x plus a -3x. If you haven't done this problem yet, pause me now. Go do the problem. Come back. All right, so -5 is what my input should be. So instead of j of x, this should be j of -5. Instead of -2 times x, this should be -2 times -5. Instead of -3 times x, this should be -3 times -5. Right? So everywhere I have an x, I'm putting a 5 instead. So j of -5 is equal to 3 plus -2 times -5 is 10, plus -3 times -5 is positive 15. So 3 terms. I simplify each of these terms, and now I can add them up. So 10 plus 15 is 25, plus another 3 is going to be 28. So j of -5 is 28. All right, pause, try the next one. Okay, g of -6. So I'm going to take g of x, which is x squared minus 4. And I'm going to substitute. So I'm going to substitute a negative 6 for the x and a negative 6 for the x here. Remember to put it in parentheses. Everything you substitute in for x is being squared. So the negative and the 6. So just so that I don't accidentally multiply negative 6 times 2, which would be wrong, I could rewrite it like this. Negative 6 squared is negative 6 times negative 6, which is positive 36. And positive 36 plus negative 4 is 32. So g of negative 6 is 32. All right, try number 5 on your own. Pause the video. Try number 5. Okay, they're not asking us to find f of 21. Do you see how x is inside the parentheses here? So we will not be replacing x. Instead, we're going to replace f of x with 21. So I can get my equation up here for f of x, and I can write in negative 3 times 5x plus 8, and equals, I'm going to say instead of f of x, I'm going to say 21. So I'm substituting, now I'm replacing this whole function notation with the number 21, and now I need to solve. Well, I've got parentheses, and I don't want them, so let's distribute. So I got 21 is equal to negative 15x plus negative 3 times 8 is negative 24. 2 terms. This one has an x in it, so let's keep that, and let's get rid of the negative 24 by adding a positive 24 on both sides. So 24 plus 21 is 45. 45 is equal to negative 15x. All right, the negative 15 is multiplied times the x, so I'm going to divide. And I saw a lot of people do this on the last quiz, which isn't wrong. It's fine. But when I divide a negative 15 by x, the 15s are the only thing that cancel. I still have that negative sign, right? And over here, 45 divided by 15 is 3. So if negative x is equal to positive 3, take the opposite of both sides. Positive x is equal to negative 3. If you don't want to have to do this extra step, if a negative number is being multiplied times x, divide both sides by a negative number. So 15 divided by 15 is 1. A negative divided by a negative is a positive. And then my answer is just going to be 45 divided by negative 15, which is negative 3. All right, pause the video, try number 6. H of x is the function I'm looking for. So that's this one. Right? And I'm going to replace h of x with what it's equal to. So I'm going to take h of x out, and I'm going to replace it with a 5, because h of x and 5 are the same thing. So now I'm trying to get x by itself. They asked me to find x, which means solve for x. I could add a 7 to both sides, but do you remember this trick? When we have a number in the denominator we don't want, we can multiply every term both sides by that denominator. Remember, every term both sides. So 3 times 5 is 15. The 3's cancel here, and I get an x by itself, and 7 times 3 is 21. So now all I have to do is get rid of these 21 positive ones by adding 21 negative ones, or you could subtract. And you could, of course, write it underneath, but this gives me more room writing it on the sides. So I added a negative 21 to both sides. These eliminate each other, and x is by itself. 15 plus negative 21. I should be able to do this in my head. Oh, my calculator's dead. It's been a long day. 15, I'm going to say minus 21 is negative 6. There it is. X is equal to negative 6. All right, pause the video. Try the next one, number 7. Okay, so j of x is what they're talking about. So let's go find j of x. J of x is equal to 3. I'm going to change minus 2x to plus a negative 2x. Plus a negative 3x. So let me just check and make sure I wrote down my function right. And now they're saying that j of x is equal to negative 8x. So I'm going to erase this. So I'm taking the j of x out, my function notation out, and I'm replacing it with negative 8x. And now they're asking me to find x, so I'm going to solve. The first thing I'm going to do is simplify. On this side, I've got 3 terms. So this is 3 positive ones, 2 negative x's, 3 negative x's. I can add the x's together. 2 negative x's plus 3 more negative x's gives me 5 negative x's altogether. I'm trying to get x by itself, and I've got an x term on both sides. That's not going to help me. So if I get rid of these 5 negative x's, I'll have the 1's all by themselves and all the x's right there, right? So to get rid of 5 negative x's, I'm going to add 5 positive x's to both sides. 5 negative x's and 5 positive x's eliminate each other, and I got 3 1's over here. 8 negative x's and 5 negative x's gives me 3 negative x's. All right, negative 3 times x, the inverse of that is dividing. I'm going to divide by a negative 3, so I don't have to deal with the negative x later. So 3 divided by 3 is 1. A negative divided by a negative is a positive, so the only thing over here is a positive x. On this side, positive 3 divided by negative 3 is negative 1. All right, pause it. Try number 8. Number 8, we need g of x. Let's go get it. G of x is equal to x squared minus 4. G of x and 45 are the same thing. That's what equals means. So I can replace g of x, or substitute for g of x, the number 45. And now I have an equation with a variable and I can solve it. Well, the first thing I need to do is get the x squared by itself. I want to take the square root of both sides, but I don't want to take the square root of x squared minus 4. That is messy and complicated. Instead, I want to have the x squared by itself when I take the square root. So to get rid of these 4 negative ones, I'm going to add 4 positive ones. And you notice I didn't change it to plus a negative 4. I just see this as a negative 4. I hope you do too. Once you see that, it makes everything else easier. So negative 4 plus positive 4 is 0. And I get x squared is equal to 49. All right, now that x squared is by itself, now I'll take the square root. So the square root of x squared is going to give me x. And if I take the square root of one side, I'm going to take the square root of the other side. The square root of 49 is 7. But we know it's also negative 7. Because negative 7 totally works. If I plug this negative 7 in here for x, I would have 49 is equal to negative 7 squared, which is true. So there are 2 correct answers to this equation, and you need them both, negative 7 and positive 7. All right, problem number 9. F of x is equal to 4 minus 15x. Oh, and we're finding x. So let's go get f of x. F of x is equal to negative 3 times 5x plus 8. All right. Now, if f of x is equal to this expression, 4 minus 15x, then I can erase f of x, and I can replace it with 4 minus 15x, right? All right, let's solve this. So I'm going to leave this one alone for now, although I am going to do my subtraction to adding a negative. And on this side, I'm going to distribute to get rid of the parentheses. So I've got negative 15x plus negative 3 times 8 is negative 24. Okay, now I've got variables on both sides, so I want to get all the variables on one side. To get rid of these 15 negative x's, I'm going to add 15 positive x's. If I do it to this side, I'm going to do it to this side. So on this side, I get negative 24. On this side, do you see that negative 15x plus 15x is also going to eliminate on this side? And all I get is 4. Do you remember this? It's been a really long time. So our variable's gone. They asked us to find x, and x is totally missing. Our whole goal was to get x all by itself, and we can't because it just dropped right out of our equation. So this is one of those special cases. And because 4 is not equal to negative 24, I know there is no solution to this equation. Or you could say it will never be true. If they ask what value of x would make this true, none of them. It can never be true. You can try values of x all day. It'll never, ever work. All right, try number 10. Pause me. Try number 10. All right, so they're talking about j of x, so let's go get j of x. J of x is equal to 3 plus a negative 2x plus a negative 3x. And I'm going to replace j of x with what it's equal to. J of x is equal to 3 minus 5x. So that's what I'm going to substitute in. Everybody still with me? You can't respond, so I don't know why I asked. So I'm going to change that. Instead of minus 5 positive x's, I'm adding 5 negative x's, is equal to, when I simplify, I get negative 5x. You might notice right here, this is exactly the same thing. 3 positive ones, 5 negative x's, 3 positive ones, 5 negative x's, but we'll keep going through the motions. I'm going to try and get all the x's on one side by adding 5 x's, but you probably know it's not going to work. These are going to eliminate and give me a 3, but this positive 5x and this negative 5x is also going to eliminate and give me a positive 3. So, like this one, my variable is gone, right? I was trying to find x, and instead I've got 3 equals 3. But I know, since this is a true statement, 3 does equal 3, that the answer is infinite solutions. Or I could say this equation is always true. You don't need to ask me to find a value of x that'll work in this equation for you, because you can use any number for x you want and it'll always work. It is always true and it has an infinite number of solutions. All right, thank you so much for going over this with me. I hope it's getting a little bit more clear.